Hi, this is your math facilitator, Naomi Andrack. This is an example on solving a system of equations by elimination. And this one, even though you start out, it looks okay, you don't think there are any fractions. This is one of the ones where it turns out there are fractions. So you ran into the fractions and you're like, oh, fractions. But the way I like to do these is by eliminating twice instead of eliminating and substituting back in. I find that students who have difficulty with fractions really prefer that method over the other method. Okay, so for this particular problem, I might start by saying, okay, I'd like to eliminate my y's. But if I just add these equations or subtract these equations, it doesn't eliminate my y's. Add them, I get negative y. If I were to subtract them, I'd get 5y. And I don't want 5y or negative y. I want the y's to go away. So what I'll do is I'll find a number that both 2 and negative 3 divide into, and that's going to be 6. So 6 is a multiple of 2. 6 is also a multiple of 3. I'm using 6. It's the smallest number. You could also use something like 12, but it's easier if you use the smallest number. Okay, so I'm going to start. I would like this 2y to be 6y, so I'm going to multiply this entire equation by 3, because I can multiply a whole equation and it's still going to be true. So I multiply that top equation by 3. 5x times 3 is 15x. 2y times 3 is 6y, and negative 7 times 3 is negative 21. So I have this new equation here, 15x plus 6y equals negative 21. Then I go to the second equation. Instead of having 6y, I want to have negative 6y, so that when I add them, they go away. So I multiply everything here by 2, so that I'll have negative 6y. So multiply it by 2. 7x times 2 is going to be 14x. Negative 3y or minus 3y will be negative 6y or minus 6y. And then I'll have that equal to 26. So this is my new equation. Now I see that if I add these, going straight down, add my x terms, add my y terms, add my number terms, the x's will go away, so that makes me real happy. So I add these, I get 29x, 0y, that part just goes away. And then negative 21 plus 26 is 5. Now I have an equation with just x. I can solve it because it just has one variable. So I divide both sides of this equation by 29, and that gives me x equals 5 over 29, just a fraction. Okay, now here I have the option. I could take this and substitute it back into the equations. Then I'd have to do 5 times 5 29ths and subtract that from both sides to solve for the y. That might get kind of yucky, so I would prefer to just repeat this process where instead of my y's canceling, my x's will cancel. So here I am. If I want my x's to cancel, I'm going to have, looks like 35x and negative 35x. So maybe the first equation I multiply it by negative 7, because that'll give me negative 35x, and then I'll have 35x, and when I add them, the x's will go away. So if I multiply everything times negative 7, this will be negative 35x minus 14y equals positive 49, because the negative times the negative is positive. On the bottom, to make that 7x into positive 35x, I multiply both sides by 5. So if I multiply this equation by 5, that's going to be 35x. This will be minus 15y, because 3 times 5 is 15. And that'll equal 13 times 5 is 65. So this is my new equation. That should be a negative minus 15y. And then when I add them, pretend that's minus 15y. This will be negative 29. These will cancel. This will give me 114. And then when I divide, I have to divide both sides by 29 to get y, or negative 29 to get y. I'll have 114 over negative 29, and I just take that negative out front. So you see that the solution to this, gosh, that's bothering me. That should be 15, not 30. The solution is xy, so the solution is xy equals 5 29ths, negative 114 29ths. Okay, I hope this helps. Bye.